Hi students, in this class now I am taking some applications related to the resistors series and parallel combination. Okay, and now we are taking one example here, and this is one resistor. It is in the circle, nothing but it's a uniform ring, and this is the uniform ring. Now this is the center O. Here we are taking 2 points, and those 2 points are, one is P and the other one is Q. One is P, the other one is Q. So now here, and this combining like this, the center, at the center the angle is theta. At the center the angle is theta. Now here we are taking the concept as, this is POQ is one segment, POQ is one segment, and this is PQ is another segment. This is another segment. It means one uniform ring, one ring is divided into 2 parts. The total resistance here we are taking it as R. Capital R is the total resistance. But here in between the points P and Q, this is one arc. This is one arc. OPQ is one arc. Now this consisting of some resistance, the remaining part of the circular, nothing but uniform ring, consisting of another resistance, some other resistance. Okay, so now here we are taking the concept as, at first for these concepts here we are taking the topic it as resistance per length. Resistance per length. We are taking resistance per length. Listen carefully, very easy. If you understand the topic, basic topic, it's very easy to apply for many topics. Okay, and now observe, resistance per length I am taking here. What is the resistance per length? Here that value is, what is the total resistance? Previously I said to you that the total resistance is nothing but capital R. Capital R is the total resistance, capital R. And then total length, what is the circumference? The radius is R. The radius is R. The radius of the circle is R. So total length nothing but circumference of the circle. Circumference of this uniform ring, and that is 2 pi R. 2 pi R. So capital R by 2 pi R. This is the resistance per length. Okay, and now here what is the topic? If you consider the theta, what is the resistance for this segment? What about the remaining resistance? The total angle at the center is 360 degree. The total angle at the center is 360 degree. In the 360 degree, theta already eliminated. This theta is eliminated. That theta belongs to the OPQ arc. OPQ arc. Then what about the remaining angle? That is, total is 360 degree. In that theta already removed, then the remaining part is 360 minus theta. That is the angle which we considered here. Okay, and now it's very simple. What we consider is very simple. And then first here we are taking the concept it as angle at this point is theta, and this is nothing but 360 minus theta. 360 degree is equal to, what's the value? 360 degree is equal to 2 pi radian. 360 degree is equal to, what's the value? 2 pi radian. Okay, so now here we are taking the concept as per unit length, this much resistance is present. This much resistance is present. And then here we are taking the concept it as, in this length, what is the resistance having by that? What is the resistance having by that? This is, I am taking it as X. This length I am taking it as X. And this length I am taking it as Y. Y. This is X and this is Y. Okay, so now here, already you know that we are taking the topic it as arc length is equal to angle into radius. Angle into radius. So what is the arc length here? Arc length is nothing but for OPQ. Arc length is nothing but, what's the value? X is equal to, what is the angle here? theta, and what is the radius of this circle? That is r. So x is equal to what's the value? R theta. So to this segment x is equal to what's the value ma? R theta. Then what about the remaining thing? This is the y. For the y segment, here we are taking that this is the arc length, right? Then what is the angle here? 360 minus theta. 360 minus theta into, and then what about the radius? Radius remains same, that is r only. Radius of the uniform circular ring, nothing but radius of the circular ring is nothing but r. So here y is equal to 360 degree is equal to what's the value? 2 pi radian. So now here we are taking that 2 pi minus theta into r. So per unit length, this much resistance is present. Then in this x length consisting of how much resistance? 1 apple cost is equal to 1 rupee. Then 10 apples is equal to 1 into 10. In the same way, per unit length, this is the resistance r by 2 pi r, r by 2 pi r. Then x length consisting of the resistance across x length is equal to what's the value ma? So per unit length what's the value? R by 2 pi r. Then x length consisting of x is equal to what's the value here? Theta r. Theta into r. Then r get cancelled. Here we can say it as r by r theta by 2 pi. R theta by 2 pi. This I am taking that one as r1. R1. So the resistance of x length is r1. The resistance of y length is nothing but what's the value? R2. So now the resistance of y length is equal to r2 is equal to what's the value? Here we are taking that r2 is equal to same per unit length. What is the resistance here? R by 2 pi r. R by 2 pi r. Then y length means what's the value? 2 pi minus theta into r. 2 pi minus theta into r. Now we got the resistance of x length, we got the resistance of y length. So here we are taking that the resistance of x length is r1, the resistance of y length is r2. Now these r1 and r2 here we are taking in a parallel combination. Right. So now if you consider the parallel combination of the two resistors, what is the formula for that? The formula is nothing but R effective is equal to, or R equivalent is equal to, R equivalent is equal to, what's the formula ma? R1 R2 by R1 plus R2. This formula we also written as 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So if you solve that, then you will get it as R equivalent is equal to what's the value? R1 R2 by R1 plus R2. Now if you substitute R1 value in this and R2 value also in this, then you will get it as R equivalent is equal to, here we got it as R theta into 2 pi minus theta by 4 pi square. R equivalent is equal to R theta into 2 pi minus theta by 4 pi square. So here this is very simple. They given one ring, circular ring, and at the center some part of the length of the ring is making an angle theta. At the center the total angle is nothing but 360 degree or 2 pi radian. So what about the remaining angle? 360 minus theta. Then what is the radius here? R is the radius. Now resistance per length is equal to, in this topic we need to take resistance per unit length. Resistance, total resistance by total length. Total resistance is R. What about the total length? Circumference of the circle, that is 2 pi r. Here small r is the radius of the circular ring. And then with this, here for this segment, for OPQ segment, this is OPQ segment, we are taking that, what is the length? X is equal to, arc length is equal to angle into radius. Angle is theta, radius is r. And then for Y segment, we are taking that Y is equal to, what is the total angle here? 2 pi minus theta. For this Y, what is the angle? 2 pi minus theta, radius is r. Then x length consisting of r1 resistance, y length consisting of r2 resistance. So r1 is equal to resistance per unit length, per centimeter this much resistance is present. Then x centimeter consisting of how much resistance? Listen carefully. Per centimeter this much resistance is present, r by 2 pi r. Then x centimeter consisting of how much resistance? That is r by 2 pi r into theta r. That is the r1. Next, per centimeter this much resistance is present. Then y centimeter consisting of how much resistance? That is per centimeter r by 2 pi r. Then y centimeter nothing but 2 pi minus theta into r. This is equal to y. So I represent it as 2 pi minus theta into r. This r1 and this r2, these two resistances are in parallel combination. So what is the equivalent resistance? R equivalent is equal to R1 R2 by R1 plus R2. If you substitute R1 value and R2 value in this equation, then you will get it as R equivalent is equal to, this is the formula, R theta into 2 pi minus theta by 4 pi square. Got it? Okay. Now this is one circuit. This is one circuit. Okay, so now I need to solve this circuit, and this is called infinite ladder. This is called infinite ladder. Okay, so how come we solve this like this type of circuits? Now instead of taking like this, here I am taking that all are having equal resistances, and that's why instead of 1 ohm I am taking it as R ohm. All are considered as equal resistances, and that's why here I am taking it as R ohm. Now observe carefully. In this circuit we need to consider the equivalent resistance across A and B. We need to take the equivalent resistance across A and B. So such type of circuits we need to know at first how much part of the circuit is repeatedly we are getting in the circuit. How much part of the circuit repeatedly we are getting in the circuit. Are you getting ma? Okay, once again I am repeating. Listen. See, R ohm, R ohm, R ohm. This is one part of the circuit. R ohm, R ohm, R ohm. Now listen. This part of the circuit is one section, and the remaining part of the circuit is another section. Why? What is the need? What is the need? It means to simplify the circuit, here the entire infinite circuit we are taking it as two parts. We are taking it as two parts. Okay, so what is the first part? Initially whatever the circuit is present, that is the first part. From where the circuit is repeatedly present in the circuit, from there we need to consider the second part of the circuit. Okay, now see, this is the first part of the circuit. Try to understand. This is the first part of the circuit. Very easy ma. Now these same three resistors are repeatedly we are getting from here. 1, 2, 3. Again 1, 2, 3. Again we can get repeatedly, and that's why here I am taking this is one part. This is one part. And this is another part. This is one part and this is another part. Okay, so now, so this is one part and this is another part, means how come we consider that? Listen. I am taking one simple example. What is that? If you take ocean, from the ocean, if you take one glass of water to the ocean, if you add same glass of water, there is no change in the level of the ocean. In the same way, If you come across the physics part and take the earth is a huge reservoir for the charges, right? Already you know that earth is a huge reservoir for the charges. If you add some charges to the earth, if you take some charges from the earth, there is no change in the potential of the earth. What is the potential of the earth? Zero. What is the potential of the earth? Zero. It means if you add some charges to the earth, if you take some charges from the earth, there is no change in the potential of the earth, that is zero. In the same way, to the infinite part of the circuit, if you add a small part of this circuit, I am taking, this is the first section and it is the second section. Second section belongs to the infinity. So up to infinity, we don't know how many branches are there like that. We don't know. That's why infinity. So this entire part is infinity. To this infinite circuit, we are adding 3 resistors like this. 1, 2, 3. We are adding 3 resistors. So there is no change in the equivalent resistance of the circuit across A and B. So the same circuit, I am taking it as, listen carefully, listen, this is R ohm and this is R ohm and this is R ohm. This is R ohm. Okay, so now here I am taking the concept as, listen, this entire part is one section, no? Okay, so now instead of this entire part, I am taking only one resistor. That equivalent resistance is X. X. It means replace all these resistors with one resistor having the resistance is X. It means to this X, this is infinite part, to this X we are adding 3 resistors. So previously I said to you that if you add some charges to the earth, if you take some charges from the earth, there is no change in the potential of the earth. In the same way, listen carefully ma, in the same way here, if you add some resistors to this infinite resistance, then also no change in the equivalent resistance. What is the equivalent resistance here? X is the equivalent resistance. So here we are taking that here also across the A and B also the same equivalent resistance is present as X. Okay, now come to the further part. This is, once again I am taking this R and X, these two are in parallel. So here we are taking the part it as, this is R ohm and this is R plus R into X by R plus X, R1 R2 by R1 plus R2, R1 R2 by R1 plus R2. Why? Because these two are in parallel. And now another resistor is here, we are taking it as R ohm. This is A and this is B. What is the equivalent resistance across A and B? As you know that value is X. That value is X. So now here we are taking that R ohm, Rx by R plus X, this resistor and this R ohm. These 3 are in series. Now equivalent resistance is, how come? Rs is equal to series resistances R1 plus R2 plus R3. So here we are taking the concept as Rs. What is the equivalent resistance? RAB. That itself is RAB. That value is X is equal to R plus Rx by R plus X plus R ohm. Then that is equal to, X is equal to 2R plus Rx by R plus X. Rx by R plus X. Now with that, once again we are taking the concept as, take the cross multiplication here, take the cross multiplication and then X is equal to, at first take the LCM, R plus X, then R to R into R plus X plus R plus X. Okay, now if you take the cross multiplication R plus X into X, r into x, rx multiply straight away plus x into x square is equal to 2r into r, 2r square, and then 2r into x plus 2rx plus r plus x. Okay, so now here we are taking further, and here x is equal to, if you take the LCM, r plus x, 2r into r plus x plus rx, and here also you are taking that plus rx, and now rx plus x square is equal to 2r square plus 2rx plus rx. What's the value, ma? 3rx. Now take this 3rx to this side, then it became as x square, 3rx minus 3rx plus rx minus 2rx. This is minus 2r square equal to 0. Now this is in the form of ax square plus bx plus c equal to 0. Ax square plus bx plus c equal to 0. With this I need to solve the problem. For this purpose, here we are taking that so here ax square plus bx plus c equal to 0, as you know well. Then with this I am taking the concept it as a is equal to 1, take this step, compare these two, a equal to 1 and b is equal to minus 2r and c is equal to minus 2r square. Okay, and now apply the quadratic equation. Here I need to solve x value. X is equal to minus b plus or minus root over b square minus 4ac by 2a. X is equal to minus b plus or minus root over b square minus 4ac by 2a. Then x is equal to minus b is minus 2r plus or minus root over b square minus 2r whole square, 4r square minus 4a, a is equal to 1, c is equal to minus 2r square. Already here minus plus 4ac, 4 into 2, 8r square by 2a. 2a is nothing but 2. And now listen, x is equal to minus into minus plus 2r plus or minus root over 12r square by 2. And this I am taking it as x is equal to, the resistance always positive, so take the positive only here, 2r plus root 12r square by 2. Now x is equal to 2r plus, this I am writing it as 2 root 3 r by 2. Take out the 2 as common and cancel. Now here I am taking that, here remaining value is r plus root 3r. Then from this x is equal to, take the r as common, 1 plus root 3 ohm. 1 plus root 3 ohm. If r equal to 1 ohm, what's the value? 1 into 1 plus root 3, 1 plus root 3. If r equal to 2 ohm, 2 into 1 plus root 3. So this is a generalized term for the circuit which we considered in the question. Okay, which we considered in that question. Got it? So now here the basic principle is nothing but repeatedly whatever the circuit is coming, that circuit entire part is one section, the remaining part is another section. So based on that, if you separate that, then 50% of the work will be over. Okay, then what about the remaining part? We need to solve how many resistors are in parallel combination, series combination, and finally what is the equivalent resistance and all those things. And with that, here we consider like this equation. It is in the form of ax square plus bx plus c equal to 0. Once this form can be raised, then immediately we considered what about the constants a, b and c. Then after that, take this equation or formula, x is equal to minus b plus or minus root over b square minus 4ac by 2a, and thereby if you solve the concept, then you will get one generalized formula. In that generalized formula, if the circuit is whatever the shape, nothing but whatever the form we considered in the question, then immediately you need to think about this formula, x is equal to r into 1 plus root 3. If r equal to 1 ohm, then 1 into 1 plus root 3. 2 ohm, 2 into 1 plus root 3. Like that, we can consider the equivalent resistance across A and B. Okay? Right.